Hello class, this is Mr. Hart, and in this podcast we want to start a unit on electromagnetism. And so we just want to start out with a very basic question. What in the world is electromagnetism? Now, you probably have guessed this already, but it's going to have to do with electricity and magnetism. So we looked a little bit at electricity before, and we've looked a little bit at magnetism before, but now we're going to combine the two. And so the idea of electromagnetism is kind of complicated. There's a lot of mathematical equations that describe on a higher level how it works, but for right now, all we need to understand is that electromagnetism is this idea that electric and magnetic fields can influence one another. Okay, when you grow up, you probably have thought that electricity is one thing, magnetism is another. Turns out that's not the case. They're completely related. They're connected forces. They work off of each other. Okay, and we're going to see how that happens. Okay, and one of the first devices we're going to look at that shows that is the electromagnet, and this is a material that becomes magnetic when electricity flows through it. So to start this out and kind of look at the electromagnet, let's go through some history, okay? And we're going to look at one of my all-time heroes of science, okay, a man by the name of Michael Faraday, okay? This guy is just amazing, okay? One of my all-time favorite heroes. Michael Faraday is unique because he was born during a time when noblemen were the only people that did science, and he was not a nobleman whatsoever. He was the son of a blacksmith, okay, the apprentice to a bookkeeper, if I'm remembering correctly. Okay, he was kind of poor. He was a nobody during those times, okay. But fortunately, because he had such good bookkeeping skills and he was so interested in science, he'd go and visit a man by the names of Humphrey Davies, okay, who was a prominent scientist of the era, did a lot of things with chemistry. And Michael Faraday would take notes at his lecture. He would go in and pay to go to these lectures that Sir Humphrey Davies was putting on, doing these cool chemistry shows and things like that. And Michael Faraday made sure to keep notes of all the things that were happening. Well, because he did that, he presented his notes to Sir Humphrey Davies, and Sir Humphrey Davies was like, okay, that's cool, thanks. Okay, nothing happened from it. But then one day, Sir Humphrey Davies had an explosion happen and his eye was unable to see for quite some time. He had a big, huge eye patch on, couldn't see, and so he was kind of disabled in the lab for a while. And so he called up Michael Faraday to be his lab assistant, even though Michael Faraday was not a nobleman at the time. And so through a series of events in that realm, Michael Faraday came to be a great scientist. He outshines Sir Humphrey Davies. In class, we watch a documentary called Einstein's Big Idea, which has a good 20-minute clip of how Michael Faraday came to discover the electromagnet and all this. Okay, awesome guy. I recommend looking up more about him. Okay, he has an amazing story about how he kind of changed the scientific world. Okay, but one of the big things that Michael Faraday did that led to his discovery of electromagnetism was he was able to design an apparatus that showed that magnetic fields were occurring when electricity passed through them. Okay, so he invents this apparatus, which is now known as Faraday's motor. So another scientist of the time was able to show that when you put electricity through a wire, nearby compasses were being affected by this current. Okay, no one was able to really show anything more than that until this motor. So what Michael Faraday did is he had a pool of mercury. Okay, nowadays you couldn't get away with that because it's toxic and there's safety regulations, but he just had this big huge bowl of mercury, okay, and he had a huge bar magnet sitting in that mercury. Okay, now mercury conducts electricity, okay, just like any other metal, but it's liquid. So he hung this wire down into the mercury, and then as electricity flowed through the wire, through the whole apparatus, once he turned on the switch, that wire would start to move. Why? Because that wire was generating a magnetic field. Okay? Since it's generating a magnetic field, there's a magnetic field from the bar magnet. The wire moves around with the magnetic field that it's generating. So it's an absolutely astounding device that finally shows that electric currents cause magnetic fields. Okay? So this realm of electricity and magnetism being separated is no longer true. They are interconnected. Okay, and we'll soon see that they're actually one and the same. They're one force, okay, just acting in different ways. Okay, so after this discovery, after Faraday's motor, and he proves all this, okay, we now know that any type of current is going to generate a magnetic field. Specifically, if you have a magnetic field around a wire or a current flowing through the wire, the magnetic field goes in circles around that wire, with the circles getting less and less intense as you get further and further away from the wire. Okay. So in other words, magnetic force gets weaker as you get further out, but that magnetic field is in circles. Okay, which is kind of weird to think about. At the time, it was really strange because up until that point, every single force and energy and thing they knew at that time acted in straight lines. And so to think that something could act in a circle was kind of bizarre. But it's true. So any type of current will cause a magnetic field in circles around the wire. Okay. Now in physics, there's an easy way to remember how those circles move around the wire, and that is called the right-hand rule. Okay. So what you do is you simply say you have a wire that you're trying to figure out the magnetic field. You get out your right hand, put your thumb in the direction of the current, I, okay, and then how you wrap your fingers around, okay, is the direction of the circles for the magnetic field. Okay. So if you imagine thumb in the direction of the current, wrapping those fingers around, that's the same direction as those circles for the magnetic field. Okay. So let's try an example problem with that. Let's think about this. Okay. So let's say we're trying to draw the magnetic fields around this wire. Okay, current's going in this direction. So if you can imagine, if you put your hand around that wire, okay, imagine we're using your right hand to put around that wire. So what's going to happen is, if you kind of visualize with me, is the current's going to kind of flow into the board in this direction and come back out on this side. Okay, if you can kind of visualize that. I'll erase this part right here. Okay, so you can kind of imagine a circle going around that wire, coming out on the top side and going back in on the bottom. Now, these weird circles I'm drawing aren't very easy to visualize for sure. Okay, so we need a better way to draw this magnetic field. Okay, especially since we're dealing with 3D, we need a better convention. So what physicists have done is they simply say when you're going into the board, we represent that with an X. Okay, so X's are into the board or into the page. Okay, and then O's are out of the page. Okay, sometimes they'll put little dots in the center too. So you can imagine on this side of the wire, the field is going into the board. Okay, and on this side, it's coming out of the board. Okay. And one way to visualize that or remember that is like if you had an arrow with the feathers on the end, if you shoot the arrow away from you, you'd see the feathers leaving you. So that's why we kind of think of the X. And if the arrow is coming towards you, okay, then you just see the tip of the arrow or the kind of the stone, the circle, arrowhead. Okay, that's how some people like to think about it. Either way, so X into the board, O out of the board. All right, so this is all fine and dandy to think about and look at the magnetic fields, but could we actually use this discovery in a practical application? Okay, to say that you can would be the biggest understatement in the entire universe. So one way we could do that is to direct the magnetic field, and the way we do that is with a solenoid coil. Okay, so what a solenoid coil is basically you take some wire that you're going to put some current through, and you wrap them around in these circles, okay, kind of like in a column almost, okay, kind of making this tunnel. And what happens is if you think about kind of following that with the right-hand rule, that magnetic field that's occurring, the magnetic field's always pointed in the same direction in that solenoid. So throughout that solenoid, the magnetic field is facing the same way. So if you add more and more and more circles, that magnetic field gets stronger and stronger and stronger and stronger, okay? Then if you put some ferromagnet or some piece of metal inside of that, and then you have an electromagnet. So you direct all that magnetic field through that coil or that solenoid. Then you put something that can actually, hold that magnetic field, like a piece of metal, and then you have an electromagnet. You put electricity through it, you got a magnet. You don't, then it's just a piece of metal. You've probably seen an example of this at like an elementary science fair, but never understood why it worked. If you have like a battery, for example, and you wrap a nail with the wire, it will start picking up other nails. Okay, that's an electromagnet. Coil of wire, current flow, and a piece of metal to grab things. That's going to be your electromagnet. Okay, let's demonstrate how this works. One common way to do this is with what they call a horseshoe magnet. So you have two different coils of wire wrapped around a bar or a piece of metal, and when the current's going through, it's a super strong magnet, and when it's not, then it's just a piece of metal. Okay, let me show this demonstration. And as you can see, right, when it's just off, there's nothing that does, it's just a piece of metal. But once I hook up the wires and put some power through those wires, then the magnetic field starts to generate from the current, and then it can start picking up some pretty heavy object. Okay, that piece of metal I'm picking up is about 20 pounds. Okay, so it can be a very strong magnet. In fact, there's some very strong electromagnets out there. A common application of this is with scrapyard magnets. Okay, those giant movers of metal and scrap that they use. Okay, those are giant electromagnets. They can put some current through those bad boys, and if they have enough, they can pick up a whole lot of metal with those things. Okay, but again, just coils of wire around a piece of metal. That's an electromagnet. Okay, and then last of all, another application of this that you'll see is with roller coasters. In class, we watch a little clip from Disney talking about the rock and roller coaster in Disney World's Hollywood Studios. And I've actually been on that roller coaster. It's pretty awesome. But what they do is along the track, they shoot you out of the track right at the start. And along that track, they have a bunch of electromagnets. And what they do is they don't have any of them on to start, but they'll slowly turn them on in succession so that they go down the line and they'll shoot you out of the track and you'll get faster and faster and faster. But it works well because they can turn off those magnets when the new car's coming in so it's not repelled. And they can wait until the ride starts to turn them on and shoot you off. So great application of this. But you can just see that electromagnets are everywhere. Anytime you're putting electricity through something and something else is moving because of it, you got an electromagnet somewhere in that device. Okay. But that's all for right now. We'll get into a whole lot with electromagnetism and how it's totally changed the world. But for right now, just think about electromagnets, how if you put electricity through a wire, a magnetic field is generated. Hopefully that all made sense. Let me know if you have any questions, and thank you for watching.